Hello and good day, good morning, good afternoon, good evening to you out there wherever you are in the world. This is Samuel and I can welcome you to this channel, the Edisam Educators channel. So in this our lesson, our physics lesson, we are continuing our lesson, our tutorial on motion, as in we are actually doing calculations that has to do with motion. So calculations, acceleration calculations, distance calculations. So this is our third example today. In today's example, please take time to really pay attention and follow me painstakingly. Make sure you get your pen and your paper. Write down the questions and write down all I'm going to write down. I might have to rub the question along the line due to space constraint, so as to have enough space to solve the question. So here, this particular questions is a question that involves three parts. We have an acceleration part, we have a uniform velocity part, we have a deceleration, a retardation aspect. So when something is accelerating, that means the velocity is increasing from an initial value to a final value. When it's moving at uniform velocity, it means that over a certain period of time, the velocity is constant. The velocity does not change. The velocity remains at a particular value. Okay? Then when it's decelerating, that means it's moving from a certain value of velocity, a high value, and going down to a lower value. So let me read the question and I'm going to interpret the question to you. But before we go ahead, if you are not subscribed to this channel, make sure that you hit the subscribe button. Go ahead and subscribe, and at the end of the day, please like the video because you are going to actually enjoy this lesson. And you drop your comments on how we can actually help you better. And if you have any question, drop your comments. Also, in case you want to connect with me one-on-one, either maybe you need a private lesson or there is anything you want to ask, this is my WhatsApp number here, +234 803829 5185, and this is my Instagram account also as well. So let me go ahead and read the question. So the question states that a car starting from rest accelerates until it reaches a velocity of 10 meters per second in 10 seconds. It maintains this velocity for another 8 seconds and then decelerates uniformly to rest in a further 10 seconds. Find the distance covered during each stage of the motion. Find the average velocity over the entire period, over the whole period. So how do we solve this now? Now, let me go back and read the question. As I'm reading, I'm going to interpret what is happening in this question. A car starting from rest. So, accelerates uniformly until it reaches a velocity of 10 meters per second. The car started from rest. That means the initial velocity was 0. And the car now accelerated till the velocity increased to 10 meters per second. Within a time of 10 seconds, the time taken for the velocity to increase from rest, which is 0 meters per second, to 10 meters per second, the final velocity is 12 seconds. Okay, so this is the first part of the journey, the acceleration. This is the acceleration. So let me take that down and write, because the first stage of the journey is the acceleration part. So for acceleration, we have that the car started from rest. So initial velocity u is 0 meters per second. Okay? It accelerates till it reaches a velocity of 10 meters per second. So acceleration here is what? No, sorry, the final velocity is which its reach was 10 meters per second. That is v. What time did it take to reach this velocity? That was 12 seconds. Okay, so it maintains this velocity for another 8 seconds. At that point where it maintains that velocity now, is not the velocity now increase. The velocity is maintaining is 10 meters per second. It's maintaining a velocity of 10 meters per second. The velocity is going to remain here for another 8 seconds. It maintains this velocity for another 8 seconds. The velocity is maintaining is 10 meters per second. So the velocity is going to remain there. That is another part. So let's hold on for that now. Let's not delve into that part of the journey. That part is where it maintains that velocity is part of uniform velocity part of the journey. The velocity will remain at that value for 8 seconds. But let's hold on and go to the question. The question says calculate the distance covered during each stage of the journey. So let's calculate the distance covered during the first part of the journey, during the acceleration part. So we have V, we have U, we have T. Okay. So we come here. I want to calculate the distance during the first part of the journey. Distance which is S during acceleration. That is during the first part of the journey. The first part is acceleration. First stage, let me call it first stage, is acceleration. So I bring my formula, equation 1. Equation 1 doesn't have distance, so I can't use it. Equation 2, S is equals to UT plus half AT squared, has distance, but it also has acceleration which was not provided, so we can't use it. Equation 3, V squared, U squared plus 2AS, also has acceleration, so we cannot use it directly. Equation 4, Vs is equals to U plus V all over 2 times T, can be used. This is distance is equals to initial velocity plus final velocity over 2 times T times the time. We can use this directly, but in case we could not use that directly, this equation here needs acceleration, this one needs acceleration. We could have just calculated the acceleration with equation 1 here. When you use equation 1 to get the acceleration, you now use equation either 2 or 3 to get the distance covered in the first part of the journey, which is during the acceleration. So since this one can actually calculate the distance directly, let's make use of it. So over here, what do we have? S is equals to U plus V all over 2 times T. So we have that S is equals to our U, which is initial velocity 0, our V, which is our final velocity, is what? 10 meters per second, all over 2 times T, which is time. Our time is what? What is our time? Our time was 12 seconds. So 0 plus 10 gives us 10 all over 2 times 12. 2 in 12 is what? 6. Or anyhow, whether you are saying 2 in 10 or 2 in 10, you will arrive at the same answer at the end of the day. So 2 in 10 is 6. 6 times 10 is 60 meters. So this is 60 meters because our units are consistent. There's not like kilometer, there's not like hour. So it's going to be meters. The distance covered during the first part of the journey is what? 60 meters. The distance covered during the first part of the journey is what? 60 meters. So distance during first part of the journey is what? 60 meters. Let me put it up there in case I rub off this calculation. Okay. So I hope you are taking down notes. So this is just it right now. So now let's go to the second stage. After in 12 seconds, they said it maintains this velocity for another 8 seconds. So maintain that velocity for another 8 seconds means that it's moving at uniform velocity. The velocity is constant, it's not changing. For 8 seconds, the velocity is not changing. So let's go. Initial velocity here is equals to final velocity. Here the initial velocity, because at when it got to 10 meters per second, the velocity is maintained. So at that point, initial velocity is equals to final velocity. This is where it is moving with what? Uniform velocity now. Velocity is constant. This is stage 2. Second stage of the journey, or second stage of the motion. U is equals to V is equals to 10 meters per second for, what is the time? Time taken for that to happen is 8 seconds. So yeah, what is the distance covered? What is the distance covered here? Distance covered here is going to be, at this point, distance covered is going to be velocity, uniform velocity is equals to distance covered all over time taken during that part of the motion. So the uniform velocity is equals to the distance covered there over the time taken in that part of the journey. Now, what is the uniform velocity? The uniform velocity is what? U is equals to V, which is 10 meters per second, equals to distance covered, which we don't know, S, all over, let me just call it S2 to show that is in the distance covered in stage 2. Or okay, let me leave it as S, don't worry. Then the time taken in this case is 8 seconds. The time taken is what? 8 seconds. So now 8 times 10, you cross multiply to solve for S. So S will come up to multiply 10. You have 10 meters per second times 8 seconds equals to S. 10 times 8 gives you 80. S cancel S. This is 80 meter equals to S. So S is what? 80 meter. So the distance covered when the body is moving with uniform velocity is 80 meters. That is the distance covered during the second stage of the journey, during the stage where the body is now moving with uniform velocity, same speed within that 8 seconds. It's not increasing speed, it's not decreasing speed. So let me call this distance to 80 meters, because I'm going to rub off some things right now so I can solve the third part. I believe you are taking down your notes. So now I want to solve the last part. They said this was where the second part stopped. Then the car decelerates uniformly to rest in a further 10 seconds. When something is decelerating, when something is decelerating, what happens is that the velocity is decreasing from a higher value to a lower value. So, and then decelerates to rest. So that means it decelerates from that speed at this point. The velocity at this point, which was 10 meters per second. The velocity at this point was 10 meters per second. They said it maintains this velocity. The velocity that it maintained here was 10 meters per second, which is this, which is what we have up to this point. It then decelerates to rest. That means it goes from 10 meters per second to 0 meters per second. Within a time frame of 10 seconds, it took 10 seconds for the car to decelerate from 10 meters per second to 0 meters per second. Okay? That was how long it took the car to decelerate. It took the car 10 seconds. So let's go ahead and calculate. But before we calculate, we have to write out our parameters. So this is a deceleration. Deceleration. This is no longer acceleration stage. This is now deceleration. We can also call it retardation. Retardation and deceleration, they mean the same thing. So this is a third stage. Third stage. So the velocity initially now it started from a velocity of 10 and went to rest 0. So initial velocity now is where it started from, which is 10 meters per second, and eventually it went to a velocity of final velocity of 0. It went to rest. So it started from 10, it went to 0, it went to rest. So what is the time frame? It took 10 seconds. So let me go back again. It started from 10 meters per second. At that point, the deceleration, that 10 meters per second that was maintained during the uniform velocity second stage, is where it started from. This is not, that 10 meters per second is now the initial velocity, and then it then decelerates to rest, which is 0 meters per second. This is final. Rest is the final velocity, 0, and the time it took is 10 seconds. So let's calculate the distance covered here. So there's no point going through equation 1, equation 2, equation 3. Okay, I can just go ahead and do this and calculate the, what do you call it? I can go ahead and calculate use the fourth equation. S is equals to U plus V. I don't want to start using first equation, all those things. The fourth equation will give you what I desire directly. So you have U plus V all over 2. So our U is what? 10 meters per second. Our V is what? 0 meters per second all over 2. Our time here is 10 seconds. So 10 plus 0 is 10 all over 2 times, this is the same thing as times 10. This t here means that the t is multiplying what is in the bracket. It is 10 seconds. So we have 10 meters per second times 10 seconds. 2 in 10 is what? 5. 5 times 10. 50 meters. 50 meters is what we have. 50 meters is what we actually have. So the distance during the deceleration, during the third part of the journey is 50 meters. So we have S is equals to 50 meters. S3, 50 meters. So it is possible they could have asked you to calculate the distance during any part of the journey, but they said we should calculate the distance during each part of the stage of the journey. So from here now we can calculate the total distance during the entire journey by adding the distance during stage 1 plus the distance during stage 2 plus the distance during stage 3. So let's get the total distance covered during the entire journey. Although we're not asked, but let's get it. That will be distance covered during stage 1 plus distance covered during stage 2 plus distance covered during stage 3. Okay? So that will be the distance covered during the entire journey. Okay? So, and also, they could have also asked us to calculate the acceleration during the acceleration and the retardation. There will be acceleration during the first part because the body is accelerating. There will also be acceleration or deceleration during the last part, the third part, because the body is decelerating. During the middle, the second part, the body is moving with uniform acceleration. There is no acceleration there. Acceleration does not exist. Acceleration there is 0. The body is not accelerating during the second part of the journey. Acceleration is 0. No acceleration occurs there. But during the first part, there is acceleration. During the third part, there is a deceleration. Those acceleration can actually be calculated. You can actually use the first equation of motion to calculate that. So I will come back to that. Let me just do what the question says we should do. The second part of the question says that find the average velocity over the entire period, over the whole period. How do we do that? How do we find that? How? The formula for the average velocity over the entire period is that average velocity over the entire period is equal to the total distance over the entire period during the entire journey from stage 1 to stage 2 to stage 3 over the total time taken as well during the entire period. Now, total distance taken is that we are going to add all the distance together, which is what? 60 meters. The first part of the journey was 60 meters. Second part was 80 meters. Third part was 50 meters. So we're going to add that together. 60 meters plus 80 meters plus 50 meters over the total time taken. The first part of the journey took 12 seconds. The second part of the journey took 8 seconds. The body moved with uniform velocity for 8 seconds. Then the last part of the journey, the body decelerated to rest in 10 seconds. Took 10 seconds. So when we add 60 plus 80 is 140 plus 50 is 190 meters. Total distance traveled is 190 meters. So the total distance traveled, in case you were asked what is the total distance, is 190 meters. Then 12 plus 8 is 20. 20 plus 10 is 30. So 30 seconds, because these are in seconds. 0 cancels 0. 19 divided by 3 is going to give you 6 point something. So let's find out. Let me punch my calculator and find out what it's going to give. 19 divided by 3. That is 6.3 to 1 decimal place. 6.3 meters per second to 1 decimal place. .3 meters per second to 1 decimal place. To 2 decimal places, 6.33 meters per second to 2 decimal place. So this is the average velocity here. This is the average velocity. Then I said something that, how about if you were asked to calculate the acceleration during each stage of the journey. In the first stage, what will be the acceleration? Let's calculate the acceleration during the first stage. So this formula here, v is equals to u plus at, can actually do justice to that. During the first stage, the initial velocity was, the body started from rest, 0. The final was 10 plus acceleration, we don't know, that is what we're looking for. Time taken was 12. So this is 0 will go, because if you add 0 to anything, it will still be 0. 12 times a gives you plus 12a. Plus 12a plus 0 is plus 12a. So equals to 12. 10 is equals to 12a. 10 is equal to 12a. Solve for a. This becomes 10 divided by 12 equals to 12 divided by 12. 12a divided by 12. 12 cancels 12. 10 divided by 12. Let me get the value for my calculator. 10 divided by 12. That is 0.83. 0.83 meters per second square. So the acceleration is 0.83 meters per second square. Then during this is the first stage now. Acceleration for first stage. During the second stage, the body is not accelerating. The velocity is uniform. So there is no acceleration. Acceleration is 0. No acceleration here. When the body is moving with uniform velocity, it doesn't have acceleration. No, there is no acceleration. Acceleration is 0. There's no point. If you calculate it, you end up with 0. So there's no point even wasting your time to go ahead and calculate. Then during the third part, where we have the acceleration, let's work it out. We are still going to use equation 1. V is equals to u plus at. In this case, initial velocity is 10 meters per second. Final velocity is 0. The body goes to rest. Final velocity. Acceleration is what we're looking for. We don't know. What is the time? It took 10 seconds. So this is time times 10 seconds. So you have 10 plus 10 times a. You have 10a. 10. You bring 10 to this side. The 0 will just go. If you bring 10, this is minus 10. 0 minus 10 is still minus 10. So you have minus 10 equals to 10a. Now solve for a. This becomes 10a divided by 10 over minus 10 divided by 10. 10 cancels 10. 10 cancels 10. You have that a is equals to 10 in 10 is 1 here. 10 divided by 10 is 1. 10 in 10, a. So you have minus 1. So a is equals to minus 1 meters per second square. Now what is the job of the minus? What is the job of the minus? Why are we having the minus? The reason why we are having the minus is that this is the acceleration. The velocity decreased from a higher value initially now to a final value. There was a decrease instead of an increase. So when we now subtracted final minus initial, the value is now negative. That is just the reason. The negative value tells you that this is a deceleration. This is a retardation. So acceleration is equals to minus 1 meters per second square. If they ask you to calculate the acceleration, you state it as 1 minus 1 meters per second square. But if they told you calculate the retardation, at the end of the day, you just write retardation is 1 meters per second square. The acceleration is 1 meters per second square. But acceleration is minus 1 meters per second square. When you attach that minus and you say it's acceleration, somebody will know that this is a retardation you are referring to. this is a deceleration you are referring to. But if you just use the word retardation, they will know that you don't need to attach the negative sign. They will know directly that this is a retardation. Okay, so we've come to the end of this calculation. So this calculation, this particular one had a lot of as in children, a lot was involved. So it's actually easy, but you have to pay the price to learn. What you've jotted down, just play the video again as many times as possible till you have a good understanding. If there's any way you're not clear, you can contact me either via the comment section or through WhatsApp. Okay, so go ahead and contact me, and in case you need a one-on-one lesson, whether online or privately, you can contact me. So thank you so much for joining us. Hit the subscribe button if you're not subscribed. Click on the bell icon and set it to all so that you always be notified whenever I upload a new video. And also like the video, drop your comment on how we can serve you better, share it with others as well. Thank you for joining us. We are still going to have another lesson. In our next lesson, we are going to deal with distance time graph and velocity time graph. How to solve motion problems, motion calculations using distance time graphs and velocity time graphs. So watch out for our next lesson. Thank you and God bless you.